Hello and welcome to this week's OAuth Happy Hour. It is just me this week. Micah is on vacation, so I'm taking over and I will be here with you today, this morning, or afternoon, or evening, or wherever you are joining from. So, as always, happy to answer questions and talk about your questions. I've also got some updates to share, and I've received a couple of questions in email and other places that we can talk about as well. But really, we're just here to hang out and talk about OAuth today, and uh, should be a good time. I hope Micah is enjoying his vacation. So if you are here, say something in the chat so I know you're watching, and introduce yourself, and we'll get started. We're on YouTube as well as Twitch today, so if you are joining us from either of those platforms, thank you very much. So I guess let's start with a quick update about a new draft that it just came out this week, actually. This is an interesting one, and I thought it was brought up um, out of nowhere essentially, and it's a very good point and a very tricky situation, and it's a good solution to it. So let me bring this up on the screen, and I will I will share this with you. Hi, Jake, in the chat. Nice to see you. Except now you've identified yourself, so you're no longer unidentified. Let me grab this screen here. This one. So this is an interesting new draft, and the draft is called OAuth 2 Authorization Server Issuer Identifier in Authorization Response, which is a whole lot of words. And it's actually a lot simpler than it looks. The What it's doing is it's adding one thing into OAuth. So this is all it's really doing. And what this is doing is saying, you know how in a normal OAuth flow, when you get back the authorization code and the state in the redirect, that's normally all that comes back in that redirect. This is adding a new parameter called ISS, which is short for issuer, which is really the identifier of the OAuth server. So it's actually a very simple mechanism. There's not much to it, right? It's just saying the OAuth server is going to generate this authorization code, and then it's going to say, here's the code, and also this is who I am, and it's returning its own URL back in that response. This is tricky because this is a front channel redirect, right? Where we always talk about front channel versus back channel. Anything going through a browser's address bar is a front channel message passing. And when stuff is sent in the front channel, it can't really be trusted because it could be swapped out. But it turns out that so normally, like if people were talking about adding things to this redirect, I would be like, well, that's not really useful because it's not, you can't trust it at that point. But it turns out that in this case, it actually doesn't matter. It actually works out to our advantage. The What's happening here, this is really only a problem if an application is configured to use multiple OAuth servers. So if an application is, if a client application is configured to work with multiple OAuth servers, where it might be because you have multiple identity providers, you want, sign in with Apple, sign in with Google, and if those are not like hard coded and pre-configured, then and if it's all actually being done by the application and not sort of like delegated out to a single identity provider, if all of that is true, then there is the possibility that somebody could impersonate a new authorization server and try to trick your application into sending an authorization code to that authorization server. It takes a lot to pull this attack off, and it really only works in a couple of cases, but this is the solution to it. So essentially what this is a way for the OAuth server to say, this is the this is who I am, and here's the authorization code. You should only ever send it back to this authorization server. Because again, somebody could just drop this into your application, like call your application's redirect URL and try to trick your client into sending this authorization code to some other server. Jake says, or now identified aerial stalker says, that is happening to me seriously. I'm very curious what your application, what your use case is, and what your configuration is that actually enables this attack. So yeah, so by the OAuth server saying, all right, here's who I am, only ever send the authorization code back here, it lets the client know not to even attempt to send the authorization code to somewhere else. The rest of this is mostly just sort of boilerplate stuff and stuff that has to go into specs. And I think, oh yeah, then there's some talk about how it relates to JARM, which is another extension. But really, it's a relatively simple mechanism that does, in fact, solve that attack. I feel like I need to do a better job of explaining the actual attack and the preconditions for that attack because it is pretty confusing to sort of imagine the different players involved. It's a little bit more obvious if you imagine that a client does discovery to find the OAuth server information. So like if I look at my OAuth server's discovery document, here is, I should move my window so that the happy hour isn't on top of it. Okay. So if I look at my discovery document for this OAuth server, here's the issuer, which is, identifying this OAuth server. Did not mean to click that. And other properties in here are the authorization endpoint and the token endpoint. So if a client is, I don't know why the screen's flickering. If a client is configured to use discovery to find the authorization endpoint, then if the client can be tricked into fetching a different document here that advertises a authorization endpoint of a real server, but then token endpoint of a different server, that client could be tricked into getting a real authorization code and then sending it somewhere else. So the idea would be that an attacker would publish one of these documents, these discovery documents, and somehow trick the client into using it to discover the URLs, where it then puts the real OAuth server's authorization endpoint in here, but the attacker's token endpoint. So that's sort of, I think that makes a little more sense. And yeah, this is the OAuth server. So there's a question here about whether this is OpenID Connect or OAuth. But yeah, this is the OAuth server metadata. There's a similar metadata document for OpenID Connect, and it's the same idea. But if you're only doing OAuth, then there's no OpenID information in this document because this is the OAuth server's document. I forget the URL for the OpenID Connect one. There it is. So like here's the user info endpoint because this is the OpenID one. But same idea, same problem, right? This document says send users here to authorize, send the authorization code here to get the token. And if someone can publish a fake document and trick a client into using it, which I think is the real trick there, like your client has to be able to be tricked into using a different discovery document. So if you're only ever hard coding discovery documents, it's not a problem. Right. But yeah, so that was an interesting development, and there's a new draft to talk about it. This is, let's see, how do I check for that? I guess like most of the time, OAuth applications are only really ever written against one OAuth server, right? Like if you're using Okta, then like I've gone and signed up for an Okta developer account. This is my OAuth server. Oh, what is the document? This is the document. This is what I've got on my screen here. This is the OAuth server discovery document. And when I go and make a developer account on Okta, I go and register for an account. I get a URL like this. I get my custom, username. at Okta, or it's the dev blah 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 bunch of numbers one, and um, I'm going to then like write code and put this into my code. So like this is my, I think I have my sample code up here somewhere. Let me share my full screen. See if this works a little better without the flickering maybe. Um, when I go and too many windows. Yeah, here's my sample code from the last time I did a test. So, oops, sorry, this one. So like this is a really simple example of a OAuth client. It's all in one file. It's whatever, not super complicated. I would never. This is not production code. This is just a demo to do an OAuth flow. But you can see here what I've done. The first thing I've done is I've hard coded my OAuth server. So what that means is that this client, because it hard codes the OAuth server, wouldn't be vulnerable to this mix-up attack. Because I'm only ever going to be sending tokens to things at this URL. If my client was configured to, for example, let a user type in their own OAuth server, because I need to, I don't know, do support users at different organizations, that's when it becomes a problem. So if this value could be user supplied, then you have that problem where someone could publish a fake document, a fake discovery document here and trick the client into doing bad things. So yeah, does that kind of make more sense? It's if you're doing this where you're like just hard coding this URL where you're only ever talking to one server and you know the ones you're talking to, you don't have this problem. Your client can't be tricked into sending authorization codes somewhere else. So yeah, it's an edge case. It's definitely an edge case. And I one of my pieces of feedback to this spec was to add text to clarify when it is actually a problem. OAuth clients that interact with only one authorization server are not vulnerable to mix-up attacks. So that was my suggestion to add that because I wanted just to make sure that if you're only using one OAuth server, you know you don't really have to worry about this. And yeah, if it's not specific to Okta. I just mean that like when you go and write an OAuth client, if you're only ever using one OAuth server, this is not a problem. So yeah, um, it's a little bit tricky, a little bit confusing, but it's important to get this stuff right. All right. Any other questions about that? That was a fun little update in the OAuth world, and I think it's interesting to see this stuff and see how it develops. And like this is, you know, somebody just discovered this potential problem and then found a solution and wrote it up, and now the group is talking about it, and will um, you know, hopefully eventually roll into the spec. Oh yeah, one of the other pieces of things to note here. This URL is draft Meyer zu Seelhausen, not draft IETF, which means it is still an individual draft and has no official standing whatsoever. It is somebody's idea, and they brought it to the group. And if the group agrees this is a problem, the group will adopt it, and then it will become part of the group's documents. So for now, it is still just an individual draft. All right. What else? What else have we got here? So here's a question from the chat. Maybe off topic, but what do you think is the best expiration time for tokens? It's not off topic. Nothing about OAuth is off topic here. That is what this stream is for. So the best expiration time for tokens really depends on a lot of things. And unfortunately, I don't have a straightforward answer for you. It depends on a lot of stuff. So things that can depend on everything from the amount of risk you're willing to tolerate to how your APIs are validating tokens to how much do you trust the app developers. So all of these things are factors in that. Some sort of general rules of thumb, though, you generally don't want access tokens to be unlimited. If you're using JSON Web Tokens for access tokens, which you are if you're using Okta, then you definitely don't want those to be unlimited. In fact, I think they can't be unlimited. And if you go too short, you end up sort of just adding network chatter in the background for no real benefit. So if your access tokens are super short, like 5 minutes or 1 minute, then every minute or every 5 minutes, the application has to use a refresh token to get new tokens. And that just starts to become too much background noise and it slows things down and there's no real benefit at that point. So somewhere in the middle, right? We don't want to go too short for access tokens. We don't want to go too long for access tokens. Probably the biggest factor for determining this is how your APIs are validating tokens. So if your APIs are doing only the local validation of JSON Web Tokens. So if you're using JSON Web Tokens, which means you have the ability to have the APIs look at the JSON Web Token signature, check that out, no network traffic, only looking at the token. You have that ability. If your APIs do that, and that's it, then you have this window of whatever your token lifetime is. It's possible that your APIs are thinking a token is valid even if it's not. So a JSON Web Token is valid for whatever time it's issued, right? You might have like 1 hour tokens. That's fine. But once a token's issued, for the next hour, that token will be valid. But the things might change, right? Like a user might get deleted, an application might get deleted, a user might be reassigned to a different group that no longer has access to an application. Stuff in the system can change after a token's issued. So that token was issued at time 0, valid for an hour. If stuff changes in the middle, which should invalidate that token, but the APIs are only ever looking at the token will look valid for the full hour. So whatever your token lifetime window is, you have this potential that your APIs might be accepting that token even if they shouldn't be. So that's sort of the trick here. That's the main consideration to have is what is your tolerance for having that potentially be incorrectly assumed to be valid. And if you have like 24-hour access tokens, for example, then you can imagine a user gets disabled in the morning, and then for the rest of the day, their application can still work, which seems bad. So you may not want to have 24-hour access tokens if you don't like that risk tolerance. But it totally depends on what app you're building, because if you're building something that's like, I don't know, showing rewards points or something, then maybe it's not a big deal if the application can still access the user's balance of reward points. So it completely depends on your application. But generally, 24 hours seems to be a common upper limit for access token lifetimes, just because beyond that it starts to get a little messy and there's more risk there. Under 5 minutes is probably too short. So generally, like somewhere between 5 minutes, 24 hours is usually a good idea. And the good news is you also don't have to make just one decision. You can actually choose different token lifetimes depending on a lot of different factors. So you have to go look at your particular OAuth server for docs on how to do this. But like, for example, in Okta, there's a little, checkboxes where you can say like, oh, if the user is part of this group, then they get this policy of how long tokens last. And if they're part of this other group, then they get longer tokens or whatever. So you get a lot of tools to do that. Related to that, how do you know how long the refresh tokens are valid? So the expires in that you get back when you get an access token, that refers to the access token lifetime, not the refresh token. So the OAuth server will respond back and say, here's an access token, here's how long it lasts, and you might also get a refresh token, which is cool. And the expires in talks about the access token only. Refresh tokens, it's a whole nother story because so if you're building an application, it turns out that it doesn't really matter if you know how long refresh tokens last. So if you think about this for a minute, if an access token expires, and if you have a refresh token, then you can write some code to go get a new access token, right? That's your that's how you can resolve the expired token case. Your access token expires, you go use the refresh token, get a new access token, carry on. Everything's happy. If a refresh token is expired, the only thing you can do is start an OAuth flow from scratch to get the user to go log in again and get a new set of access token and refresh tokens. So it turns out that it does not matter why the refresh token is invalid if that happens. So if the refresh token has a scheduled expiration date, like the refresh token is going to last 24 hours, at the end of the 24 hours, the application has to start an OAuth flow again. If the refresh token was unlimited, but then gets turned off because the user was deleted, and the app goes to use the refresh token and it fails, same thing. The app has to start over from scratch. So there's no reason to tell the application when a refresh token will expire because the only thing it can do, no matter why it expires or when, is to start from scratch. There's no code you can write to do anything else. So there's no need for the application to know. And that's why there's no indication of the refresh token lifetime to applications. But good question. Hopefully that clears that up. Okay, here's a question. Oh, I think this was from when I got an email. Thanks for joining the stream. Was wondering if there is a template one should follow to hide the client secret and the access token. Is there a template for refreshing tokens with time limits? I'm working on a Python Flask app. So let's talk about client secrets first. Client secrets are essentially the application's password, which means they have to be treated like a password. So your application should treat it like a password and only store it in safe ways that can't be exposed. Typically, and this is true with any API key your applications can be using, right? That might be your Google Maps API key or whatever it is, right? These are secrets that are meant to be known only by the application. So generally, it's let's see. You don't want to commit it to your source code, right? Don't put it as part of your source code because that's gonna. That was loud. Sorry. Don't include it as part of your source code because that's going to be shared with too many different developers and maybe published on GitHub, right? You wouldn't put API keys on GitHub. And you'll find a lot of bots now scanning GitHub repos looking for things that look like secrets and sending a warning. So a very common pattern is to put it in the environment config. So like in Heroku, for example, if you're deploying on Heroku, there's a whole section in there where you can just plug in environment variables. And that way those are not part of the code, but your code can access them. It also means if you're deploying the same code in multiple different servers, you can configure them with different OAuth servers and OAuth clients, client secrets and stuff. So that's generally how you want to deal with the client secret. It's also very important to remember that if you are building a single page app or a mobile app, you cannot use a client secret at all because there is no way you can keep it safe. So ideally you wouldn't get a client secret in the first place, but yeah, that is only applications that can keep it secret should be using client secrets. So then it takes us to access tokens. Now, access tokens are not something that you're going to be deploying at, you're not going to be including those at the time you deploy the app. Those are things the application gets after it's running. If you are dealing with a Python Flask, like a server-side app environment, then that is generally you have like a server-side session storage, right? And you can put stuff in a session that is user data and it will live there and you can retrieve it there based on the user's session they have at their browser. So that's generally where you want to store those. If you're feeling particularly paranoid, or if you don't have a session storage that's sort of just like contained within that server, if you're like using a database that's on some other remote system or whatever, like if you're feeling particularly paranoid about that, you could store it in an encrypted format. And that's a little bit safer because then as things are moving around in your backend and like maybe you have other applications sharing the database or whatever it is, um, then you reduce the risk of things getting leaked. So storing them in an encrypted format is totally doable, and lots of web frameworks have mechanisms to store things encrypted now. I don't know particularly about Flask. I do know that in Laravel in PHP there is a way to say like anything stored in this database column gets stored encrypted, and then the framework just deals with encrypting it and decrypting it when needed. And yeah, so then the third part is there a template for refreshing tokens with time limits. So again, we kind of talked about this a second ago, but in general, your access tokens are going to have some expiration date that your application does know, and it's you can either refresh it ahead of time, ahead of schedule, if you are being proactive and the token's about to expire, you can go refresh it. Or you can just wait for an API call to fail and say the token expired and then go refresh it. Ideally, you want that logic to be something that your entire application can take advantage of. So you want some sort of like your API client. Maybe that's a library you're bringing into your application, an SDK or something. Hopefully, that's where that code lives. And then anytime your app needs to go make an API call, it calls that client, which makes the API call, which that client can then be aware of how to refresh access tokens. So that's generally how you want to do it. And again, if the refresh token expires, like if the attempt to refresh an access token fails, it doesn't matter why it failed. The only thing you can do is get rid of all the tokens and start from scratch and do a new OAuth flow. So hopefully that answers the question. Let me know if you have any other follow-up questions. Is it viable to use an access token for session management and rely on cached calls to the token introspection endpoint to validate and keep the session alive? So, kind of. So there's this problem with the caching the response of the token introspection endpoint. So let me back up. The token introspection endpoint is an endpoint that actually there's two different things going on here. The token introspection endpoint is meant for a resource server or an API to validate access tokens at the OAuth server. If you do not have a structured token format like JSON Web Token, then your resource servers have to look up the token somehow, right? That's going to be either because the resource server and the OAuth server share a database because it's all just one piece of software, but more likely it's the OAuth server is somewhere else, and your resource servers have to go use a token introspection endpoint to check the access token, whether it's valid. Now, if you are using JSON Web Tokens, then you don't have to go use a token introspection endpoint because you can do JSON Web Token validation at the resource server. And if that's the case, you're better off doing JSON Web Token validation every time and only doing introspection if you want to sort of double check that a token is still valid, like the user didn't get deleted or something, and never doing any of your own caching. And the reason for that is because if you add your own caching, you're adding new places where the answer to whether a token is valid might be wrong. So if you've got a JSON Web Token and it says it's valid for an hour, or let's say it's 12 hours, and then you only did local validation, you will never know for 12 hours if a token is expired for some other reason, like a user was deleted. So if you go use a token introspection endpoint, you would know if it's valid because the OAuth server keeps track of that information. However, you wouldn't want to always use a token introspection endpoint every API request. So you might be thinking, well, if I cache that, isn't that good? The problem is if you cache it, you now add your own window during which you might be then getting the wrong answer. Because if you're looking in your cache and it says it's valid, but then the state of the system changed, you've now got the wrong answer and you've created that problem yourself. So whereas if you were using the JSON Web Token lifetime, you make it the decision of the OAuth server to decide that window, which is a more appropriate place to make that decision because the OAuth server can be more aware of different users and groups and other policies and things. So generally, I don't recommend caching the token introspection response because if you're using JSON Web Tokens, then you should be using the JSON Web Token lifetime as that window. Now, the other part of this question that makes me a little bit nervous is that I can't tell if you're talking about the API using the token introspection endpoint or the application, the client. And the client should not be using the introspection endpoint because clients do not need to introspect access tokens. Clients just use access tokens to access APIs. So if your applications, if you find yourself in a situation where your client application, just got an access token, and then you're trying to say, oh, I need to figure out if it's valid, and then I might need to cache that you're doing something wrong, because that's not what that's meant to be used for. That access token should never be inspected by the client application. It should just be used to make API requests. So feel free to clarify if because I don't know exactly what you were asking, but feel free to clarify this if you have any follow-up. Here's another question. I had a query on consent in an OIDC flow. When do consents expire? I've read that they outlast token, but are they revoked on token revocation? Is there a best practice to follow here? Yeah, that's a good question. I don't know if there is a best practice or any sort of common thoughts here. So this would apply to OAuth as well as OIDC, right? Because OAuth consent is also that's a big part of OAuth. If you imagine applications that you use, like I don't know, I sign in with stuff with my Google account all the time, right? So if you go look at your Google security settings, you will find the entire list of applications that you've authorized to access some part of your account. And it's very likely that some of those have been there for years. And it's a good idea to review this every now and then because typically those don't expire. And the tokens will expire, but the consent won't expire, which means if you go back to the app, if the tokens expire and you go back to the app and click login with Google, Google's not going to ask you, are you sure you want to grant this application permission? It's just going to redirect back with new tokens because you've already agreed. But it is completely up to the OAuth server to decide whether and when to expire those consents, and I typically have seen them be very, very long-lived. They definitely outlast the tokens, but yeah, as far as token revocation, now I feel like I need to double check this because that is an interesting question as to whether token revocation is intended to expire the consent. If I take a look at OAuth.net token revocation, let's see. So it's meant to be used for log out, but let's see if it mentions anything about consent because I actually don't remember. So token introduction. OAuth is used to log in to a certain site. The revocation mechanism allows the client to invalidate its tokens if the end user logs out. Notifying this allows the authorization server to clean up data, blah. This prevents a situation in which there is still a valid authorization grant for a particular client, of which the end user is not aware. Grants, invalidated grants will no longer turn up in a list of authorized grants. Yes. So token revocation is not just meant to log out and not just expire that particular token. It is meant to expire the authorization. So I learned something today because I didn't realize that subtlety there. Is there anything else in here that is useful? Cross origin, implementation, note. No. Okay. Cool. Token revocation. make a post request, location, endpoint, blah, blah, blah. Okay. Yeah, that's interesting. Okay. Well, fun. Thanks for the question. Um, yes. So apparently, yes, the authorization is meant to be revoked on token revocation as well. Clarification from the last question. It is the resource server. Good. Okay. So if it's the resource server that's used, we'll be using the token introspection endpoint. Here's the earlier question. Then the next question I would ask is, if you have a structured token format like JSON Web Token where you can be validating tokens without going over the network, don't add any of caching yourself. Only use either the local validation or go use token introspection. You can make your own decision about whether you're going to do each of those, that's fine, but don't add a new caching layer. Now, if you don't have a structured token mechanism and your tokens are just a random string and you have to use a token introspection endpoint, then the resource server could add its own caching layer to avoid hitting the introspection endpoint every API request. However, that's not ideal because then every API is making its own policy decisions about how long to cache that response, which is the window in which you might be getting the wrong answer by thinking a token is valid even when it's not. So that's the sort of situation that you're in there. Hopefully that clarifies that. Cool. All right. I'm caught up with the chat. I wanted to share something I was working on. Feel free to drop more questions in, but I want to share something I was working on that for experimenting with some cookie stuff and local storage stuff because I was curious to see how this stuff works and actually um, figure this out for reals. So I was doing some experiments when I was writing up this latest section of this course, and I wanted to test how local storage and session storage behave also when compared to cross-origin requests. So I made a little page here called, it's on exampleapp.com, and it has two, let me get rid of the iframe one first. It has, let's see, refresh. Yeah. There's two text areas, and one is for, I just call it session storage, one for local storage. And then here's some JavaScript. What we're going to do is grab that element. If there is something in the session storage, we're going to put it into this text field. If there is something in local storage, we'll do the same. We'll put it in this text field. So what this is doing is essentially it's mimicking like an autosave feature. So this is saying if the value of that box changes, write the value to session storage. And this one does it for local storage. So this is like a super quick little bit of sample code, right? Where you can implement an autosave feature for your form fields. So as I type in like hello world and then tab out, that is now written to session storage. And if I reload this page, you can see the value stayed. So that's cool, right? Same thing here. Hello, this is local storage. And if I reload this, it stays there. So great, I've got autosave on my form fields. What happens if I close this window and then visit the page again? This is what I was curious about. Session storage clears out when the window closes. Local storage does not. That's what those two different APIs are for. So that's pretty cool. And then I was curious, who can read this data? Clearly the code on this page can read this data. That's what it's for. But what about code in a iframe, for example, from a different domain, or brought in from JavaScript from a different domain? So let's this is demonstrating what happens if you have a cross-site scripting vulnerability, right? Here's a different domain, evilapp.com, and I have this file called evil.js. And what that's going to do is just console.log local storage and session storage, and also document cookies. Let me bring up my console now. And obviously this is not going to run if I just do this, but because this is just JavaScript. But when it is in this page brought in as a script tag, I wanted to see, can JavaScript on a different domain read local storage and session storage on this domain if it's brought in like this. So this is session storage. Okay, autosave. Now if I reload the page, check this out. So the this is coming from my evil app JavaScript, right? Console.log session storage. And it can, in fact, read the session storage and local storage on this domain, which is really interesting. And the reason this is relevant is because if your application brings in any JavaScript from any other domain, that JavaScript can read stuff that your JavaScript app has stored in session storage and local storage. And what are you going to be storing there? Probably access tokens. So if you go to look at a real website, you're going to find a ton of JavaScript being brought in from different domains, right? You're going to have your ad network, your Google Analytics, your whatever other analytics, your embedding the Facebook button, embedding whatever it is, right? Like all that JavaScript can read your local storage. And also, if your website has a cross-site scripting vulnerability, then you run the risk of someone being able to inject JavaScript and then read your local storage. So storing tokens there is a bit of a trick, because yeah, it's dangerous, right? Like anything can read that. So that was my little experiment. I wanted to see that actually in action. So I used 2 different domains and actually tried that, and it was yeah, it's concerning. Storing tokens in JavaScript is dangerous. We got a couple of questions coming in the chat. Let's see. I'm planning to use OpenID Connect for authentication of the end user in an Android app. Is that the right approach to begin with? Google OpenID Connect. If you are trying to get people to authenticate with a Google account, then yes, I would use Google's OpenID Connect. If you are, and yeah, if you're not using Google, that's the correct approach too, because the OpenID Connect is how the application will get a user's identifier, which takes us to the second part of this question. I want to keep the server infra costs to the minimum, so considering the user email ID as a unique identifier for the end user. Are there any risks or security implications? This is a great question. There are absolutely risks, and I would not recommend using an email address as an identifier. Here's the reason. Email addresses change, first of all. They're not actually permanent. People usually do have more than one. But more importantly is that many OAuth providers let somebody change their email address on their account and then also return the new email address when someone logs in. Now, again, this is usually not a problem if you only are using one OpenID Connect server or OAuth server. But if you allow people to use multiple options to sign in, like if you have sign in with Facebook, sign in with Google, sign in with Twitter, all of those as choices, sign in with Apple. If you have all of those choices available, then you run this risk where if one of those allows a user to update their email address and then without verifying it returns it in a login as the user's email, which is very common, then someone can take over someone else's account. And this has absolutely happened before, right? So if you have like a Uber, I'm not blaming Uber for this is just a theoretical example. If you have, the Uber app where they give you the option to sign in with Google, sign in with Apple, and the user first signs in with Google, and then Uber stores the email address, and then someone goes and makes the attacker goes and changes their email account on their Apple account to the victim's email, and then uses sign in with Apple, then Uber is going to think, oh, it's the same person because we matched up the email address, right? Even though it's not the same person, it's the attacker. So that's the risk of using email addresses as the user ID. Now, if you are 100% sure that every identity provider that you're using does not let users change their email addresses to and return that as the email in their OpenID Connect response without them verifying the email, if you're 100% sure of that, you could use it to dedupe accounts like that. However, I would not feel comfortable enough if I have more than like 2 providers in my app to actually go and audit that and then trust them to stick to that. So the more secure option here is to, oh yeah, so wait, let me back up. That's the security risk, security implication. The other problem with using the email as the identifier is in the legitimate case of, like this isn't going to happen with Google probably, but with like if I used my Twitter account to log into something or used a Facebook account, I might just change the address on my account, right? Like I might just say, go into Facebook and say, oh, I'm changing my email address. It's the same Facebook account, but it's a different email address. And then if I log into something with that account, with that Facebook account, and now your app sees my new email address, you're going to think I'm a different person. And now I've lost access to my account. So that's not even that's not a hack. That's not someone trying to exploit somebody. That's just a bad situation because people are going to lose their data because you're going to think it's a different person because their email address changed. So those are 2 very good reasons to not use email addresses as identifiers. The more secure option here and the more stable option that's going to avoid those problems is if you're using OpenID Connect, there is a property called sub, short for subject. Wasn't a good name, but let's move past that. And that is meant to be the unique identifier for that user on that server. So if you look at what you get back from Google, it's going to be, I think it's some really long string. Okta subject IDs are like 20 characters or something, just a random string. And it's usually not a username or email address. It's meant to just be like a identifier. That will not change if the user changes their email address, right? Like if I have my Google account and I am able to change the email address on my Google account, my subject ID is the same. So that is that is what you're supposed to use to identify a user. Now, what that does mean is if you have multiple identity providers and someone clicks sign in with Google the first time and then comes back and the second time they log in, they click sign in with Apple, you're going to see 2 different users, even though that might be the same person. So that's the trick. And in that case, you could then try to use the email address as a hint to dedupe them, but you have to go verify it yourself. So you have to do some sort of email-based, like go send them an email, say, hey, we just noticed that you signed in with Apple, but it looks like you already have an account with us from Google. Click this link if you want to merge your accounts or whatever, right? Like somehow figure out how to make that make sense to people and not be something that someone would accidentally click and give an attacker their account. But you could try to merge duplicate accounts that way. The other thing to do is after someone logs in with one of the providers, you could ask them, do you have any other providers you might want to use to log in? And then ask them to connect those right then. So if they're already logged in, and then you say, connect your Twitter account, connect your Facebook account, connect your Apple account, and then you can use any of these to sign in later. That way, you can link up all the subject IDs in your own database and map them to the same user account internally in your system. So that's how I would recommend doing that. But it is unfortunately a real problem if you have multiple identity providers as an option for people to use to sign in. Dealing with the duplicate account issue is certainly a problem. It's also known as the NASCAR problem because your sign-in page gets full of a bunch of logos of different companies, and it can look kind of messy. Oof. Okay, that was a lot. Good question, though. Thanks for the question. All right. Yeah, this stuff is tricky, but this is good. I think I am going to wrap up here, ending it a little bit early, but normally I have Micah here to do half the talking, so I'm a little bit parched. But thank you all for joining. I appreciate all the questions, and we'll be back here in 2 weeks. Although now I'm just realizing that in 2 weeks Micah is also out, so maybe I'll have a different guest on, and we'll talk about this stuff. Talk about this stuff anyway. So thanks for all the questions, and have a great rest of the day.